Hello, 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 and welcome. Is the mic on? Yes, it is. Good. I didn't check the mic before I started the stream, so I had to check it then. Yeah, that's all I got. Good morning. Happy Monday. Let's get into it today. Another wonderful lesson of math with Mr. Taco. Dividing decimals? No. 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 Let's get this right, everybody. Fractions, part one. Dividing fractions, part one. That one, right there, okay? Dividing fractions. Okay, it's a little bit of a misleading title because we're not actually going to be dividing fractions. We're going to be preparing to divide fractions today. But you are going to need something to write on and something to write with, and the icons are down below. I can define inverse operation. Okay, it's a term that we have discussed before, but are going to go into further detail on and really feel solid on what an inverse operation is. And then I can write a multiplication equation that is the inverse of a given division equation. So let's take a look at it. And up here, divide and multiply. Best friends forever, because they are what's called inverse operations. They are kind of the undo buttons for each other. Okay, it's almost like the opposite. Inverse, kind of the mathematical version of an opposite, right? If we take a look at this visual here, disregard our little place value slider. If we take a look at this visual here, thinking about what equations could we match with this visual. Okay, we've got 1, 2, 3, 4 groups, and 1, 2, 3 things in each group, 3 units in each group. Okay, so when we're thinking about this in terms of equations, we could think of it as 3 groups of 4, or 3 times 4, equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can think of it as 3 times 4 equals 12, because we're taking 3 in each group times 4 groups to make 12. Or alternately, we can think about it as 4 times 3. 4 groups of 3 makes 12, right? The other way we can think about it is starting with the total, starting with our 12 things, and we are dividing it into 4 groups. And how many are in each group? Well, there's 3 in each group. Okay? If we put that together, we can kind of see the inverse nature, right? If we start at 3, right? We multiply it by 4, we end up with 12, right? Then we take that 12, divide it by 4, and we're back at 3, right? So we're multiplying by a quantity, and then when we divide by that same quantity, essentially what we've done is we've taken our 3, we've made 4 groups of it, and then we divided that back out into 4 groups. So we end up back with the same 3 that we started with. Okay? Addition and subtraction, also inverse operations, right? If we do 10 plus 5 minus 5, we're going to get right back to that original 10. Okay? That's why I kind of think of them as the undo button. Okay? And this comes in handy when we're thinking about dividing fractions. Okay? So before we even get to the mechanics of dividing fractions, which we'll get to tomorrow, let's think about what inverse operations could we have here. So if we had something like 4 divided by, I don't know, let's say 1/5 equals, and we're going to use n, we're going to use a variable, because honestly, again, and it'll say so on the exit ticket, I'm actually not worried about what n equals today. Don't even worry about it. Okay? If you give me one answer that's a number, it's going to be wrong. Okay? Our answer today is going to be in the form of an equation with a variable. So if we have 4 divided by 1/5 equals n, okay, what would the inverse operation of that look like? Okay, if it helps to substitute with a whole number, we can think about 4 divided by 2 equals n. So n times 2 equals 4, right? And we can fill in that n equals 2 here. But if it was 4 divided by 1/5, go back to our original thing, right? All we have to do is take that inverse operation, and times 1/5 is going to equal 4. And I'll rewrite it down here. Okay? 4 divided by 1/5 equals n. Therefore, n times 1/5, and actually I'm going to use the dot instead of the x, because if we're using variables and x's for our multiplication, things can get confusing. Because is that x a variable or is it multiplication, right? So when we're working with variables, I always use the dot as our multiplication symbol. Okay, so here would be our inverse operations. 4 divided by 1/5 equals n. n times 1/5 equals 4. Essentially, all we're doing here is kind of switching our dividend with our quotient and then changing this to a multiplication symbol. Okay, that's kind of really all we're focused on today, because inverse operations are going to become really, really useful when we're thinking about dividing by fractions. In this case, right, if we're thinking about 4 divided by 1/5 equals n. Okay, we'll get a little bit into the conceptual here, just briefly. Let's take 4 divided by 2. Go back to 4 divided by 2 again, right? Equals n. What we're saying is we have 4 and this, our divisor, is the number of groups we're going to make with that 4, the number of equal groups. Okay, and then this n, our quotient, is the value of one group. We're thinking about it that way. Okay, if we're taking our 4, we're dividing it into 2 equal groups. Okay, what's the value of each group? There's 2. All right, these also, sorry, now I'm just doodling cows at this point. There we go. Okay. That's pretty cute. Sorry to waste your time, but those are really cute cows. Moving on. So if we've got 4, thinking about this idea of, actually I didn't want to erase those arrows, thinking about this as the number of groups, and then thinking about this as the value of one group, okay? If we have something like 4 divided by 1/5, whoops, not 1/15, 1/5, okay? We've got our 4 again. Now we're dividing this into this is 1/5 of a group. And n is the value of one group. Conceptually, that gets a little confusing. Okay? Which is why we're going to go more in depth into this tomorrow. But before we do that, I really want us to practice how to make inverse operations and how to think about this idea of, you have our dividend, you have our divisor, and you have our quotient, right? Being able to say, okay, I'm going to take that n, I'm going to multiply it by the divisor, by the thing we just divided by. And I will end up back where I started, because these are inverse operations. Well, I did the thing that I said I wasn't going to do. I'm going to make sure to use that symbol as a dot and not a x, because again, when we're working with variables, what if this variable was 15 divided by 1/4 equals x, right? X 1/4, right, that's why we use the dot, okay? So let's practice a couple on our digital whiteboard, just to give us, again, we're not solving these equations today. We're not figuring out what n, there's n, we're not figuring out what n is, okay? I'm really not worried about it. If you try and figure out what n is, you might end up pulling out a bunch of hair and getting frustrated, and I don't want that today, okay? We will get into, and we will, over the next week or two, discern how to solve for n. But for now, all we're doing is we're writing an inverse operation with multiplication. So let's go to the digital whiteboard here, and let's try this one. Let's start with a whole number. Let's start with a whole number divided by whole number. So remember, we're going to write a multiplication inverse to this. So let's do 12 divided by 5 equals n. Okay? So again, we are not solving for n. Not solving for n. Okay? All we're doing is we're writing a multiplication equation that uses these three terms. All right, we're going to have something, we're going to start with our n, times what equals what. And you've only got two choices here. Is it times 12 equals 5 or times 5 equals 12? All right, we're going to, because we're dividing by 5, our inverse operation has to multiply by 5. And we end up back at the start with 12. Okay, and am I seeing that in the chat? No, I'm not. Not yet. We'll get there. Okay, leave it another minute. I'm also a little bit ahead of you. So if I haven't seen it yet, probably means you haven't seen the part where I asked you to put it in the chat yet. Okay, so let's try another one. Let's do another whole number one. 28 divided by 6 equals n. Okay, again, don't want you solving for n. We are writing a multiplication equation that is the inverse of this division equation. Okay, so because we started at 28, we're going to end back at 28 using multiplication. So we're going to have a multiplication here. So what are going to be our two terms there? I see n times 6 equals 28, and I would agree, right? We're doing 28 divided by 6 to get to n. We've got to do n times 6 to get back to 28. These are our inverse operations. Okay, let's try one more, and then I'll let you get started on the exit ticket. It should have posted to Google Classroom by now, but let's try this one as a fraction. Okay, remember, because we're not solving for n, it doesn't actually change the mechanics of what we're doing here. If we had 9 divided by 1/4 equals n. Okay, what would the inverse operation of this equation look like? While you're doing that, I want to remind, same time tomorrow, we're going to get into part 2. There will be more than 2 parts. This won't just be part 1, part 2 dunzos, right? We're going to get into and dive deeper into, we're going to really dive deeper into dividing fractions on a conceptual level, because, and your parents know this, as your grown-ups know this, not just your parents, but your grandparents, aunties, uncles, cousins. When my generation learned this, all we learned was the shortcut for how to find an answer, how to solve for n, and we had no context whatsoever onto actually what it was that we were doing. But it is really important to have this context because it's building that mathematical creativity and flexibility. Okay? So I'm starting to see it pop up in the chat. We have, yep, we keep our fraction in the middle. Okay? Now we're doing times 1/4, and really it just is n times 1/4 equals 9. Okay, good question in the chat. We said, shouldn't we use some other variables than n because n would all be the same answer? Now, because variables can equal anything, and we're only dealing with one variable per problem, I guess, one variable per equation here, we're okay, right? If we were doing something like, oh, I don't know, n divided by, and we're going to make this another variable, we wouldn't want to put another n, unless we wanted those two things to be the same, right? In which case, 9 divided by n equals n. There actually is an answer for that. A whole number answer for that. But if we meant it to be two different values, we would use, 9 divided by a equals n, or 9 divided by x equals n. Okay? And then when you start a new, you start working on a new unknown, then kind of all of our variables then would reset, and they, n doesn't equal 9 divided by 1/4 forever and for everything. Okay, that's why it's a variable. Okay, the answer, by the way, to this one, 9 divided by n equals n, would be n equals 3. Thank you all for tuning in. Remember, Taco's office hour is open starting at 11 o'clock. And come for any and all math questions. Does not have to be about this lesson. We have our regular crew that like to come and do the exit ticket while in office hour, so they have questions as they go, which is a great strategy. But if you have questions on other stuff, or if you've been directed to stop by small group because of something I was noticing in an exit ticket from last week, please go ahead and do that and we'll work on it. All right. Thank you all for tuning in. Have a wonderful rest of the day. YouTube-only viewers, I will see you tomorrow at 10:30. Bye.